Hey guys, what's up? Eddie Aho here with KissAnalog.com, and we're in the lab with Ziboo. They sent me out this meter for free. Thank you very much. Now this meter, I've taken it out of the box already. Here we go. Does it look familiar? Does it look anything like this one? I guess it's in the title, right? I'm not sure what the title of this video is yet, but all right, so this is the 15B, okay? They also make a 17B. Well, they're 15B Pro, 17B Pro. Has a lot of look and feel as the 18B Plus. Now, this also comes in a 15B Plus and a 17B Plus. The 17B Plus is actually a lot more like this, the Ziboo meter, okay? The 15 Fluke is just kind of a basic one. And then they add some features in the 17B Plus, which this guy has. But then in the 18B, this one, I bought this one because it has a special diode feature. And I just thought that was kind of cool, kind of different. But I lost a couple other features in this one. The price is about the same as the 17B Plus. Okay, they're around $165, $150. Okay, now here's the thing. Similarities, they look the same, about pretty much the same size, right? The weight, the Fluke is just slightly edges over a pound, I think, and this just edges under a pound. So they're like 40 grams different, something like that. So they're pretty close to the same in every way. Kickstands, very similar. A lot of similarities. I'm going to bring the camera over. I'm going to show you these things close up. And we're going to compare. You know, one thing I thought I'd do. Here, let me just turn on the backlight on each one. What do you think? I'll try to get the backlight in similar light. Okay, what do you think? It's pretty obvious. The Ziboo has a lot better backlight display, right? You can see it from there. I just wanted to make that point. Because when we come over the bench, it'll be obvious. But I just wanted to show you, even from 5 feet away where that camera is, it's pretty obvious. So yeah, well, it turned off. There it is. So look at this thing. You can tell when I turn it off and on. Okay, this guy, wait, hold on. Can you tell? Try not to get the glare on it. Off, on. It's hard to tell. Not a lot of difference. So anyway, similarities, size, color, weight, both made in China, okay? Tolerances. You know what, guys? These both have the screen protectors on. I usually leave them on until I give them away or whatever, but maybe I'll take them off because I've had people complain before. They think it's unfair that I leave it on. So there's the Fluke. Yeah, maybe I can put it back on actually. And there is the Ziboo. All right. So I don't know if that made any difference or not. What do you think? You see one display any more reflective than the other? They look about the same to me. It looks like the same display except for the backlight. Here, let's look at the backlight again. Now that's with my lab lights on, but like I say, it doesn't, you can see the obvious difference, right? Much nicer display. Also the details, volts, DC, oops, let's change this to DC. Volts, DC. Now this does say auto, this one doesn't. If I go into manual range, let's see what happens. Oh, wait, hold it. There, yeah, it said auto there. Maybe I had hit the button or something. But okay, so yeah, auto, DC, volts. This shows the automatic timers on. This one doesn't. I think you can turn that, you can turn it off. Let me see if I got it right. Yeah, see the automatic timer turned off. So there we go. Now you can see all the functions of the display when I first turned it on, right? So there's DC. Now this also shows the DC bars up here, and you see the negative sign sometimes come on. So it looks like 4 digits, all that stuff, okay? Okay, let's take a voltage reading. Tolerances. I'm going to kind of go over those. Well, you know what? I'll tell you right now. The DC volts and DC millivolts in the Ziboo is 0.5 plus 3 digits. The Fluke, 0.5 in DC. In millivolts, it goes to 1%. Twice as bad, plus 10 digits. Okay? The Ziboo and AC, it goes to 0.8. So from 0.5 to 0.8 plus 5 digits. The AC in this one goes all the way to 1% plus 3 digits. And AC millivolts goes to, what is it? 3%, 3 digits. So, yeah, so this guy, the accuracy. Now, if you look at ohms and all the other stuff, all the other accuracies, you'll see that Ziboo does very well, okay? So, anyway, some people go like, how accurate is it, though? So, there you go. If this tests like the specs show, we'll be impressed, right? All right, so that's the similarities. Both made in China, same size and all that kind of stuff. Price, not similar. We'll talk about price at the end of the video, okay? And what else? So let's just come over here to the bench and show these things close up. You know what? One more thing that I'm thinking of. Similarities. They're both Cat 3, 600 volts. Both Cat 2, 1000 volts. Okay? So just, I've done videos on categories, the cats. Okay? That's the safety ratings. And that has a lot to do with the kind of fuses you use. And that's when you're reading current. If you're not reading current, those fuses don't do anything for you. So some people never read current with their multimeters. Therefore, those fuses, the more expensive fuses they use in the higher categories, don't mean anything. Category 1 is just sitting here at the bench, tinkering around with little electronics, DC stuff, right? Category 2 is if I open up one of these, go inside it, and start playing around. So there's AC volts present, there's all that. Category 2. Category 3 is when I go into the breaker panel over there and start messing around inside there. That's where there's more energy. That's where it's a little more dangerous to work. A lot more dangerous than Cat 1 or Cat 2. So Category 3. So this is good for work in your house and stuff like that. They're both CE rated. They don't have third-party safety testing unless they had the CE testing third-party, but that can be done in-house too. So very similar. Both made in China, both CE safety rated. Both have the same Category 3. So, yeah, a lot of similarities, guys. Okay, let's come over to the bench, take some readings, and I'm going to show you how, if this guy stands up to the specs, how this guy's going to look better than this guy, okay? So, let's do it. All right, before we do that, let me just show you the leads they come with. This one comes with these leads here, and they have kind of an angled thing like this. So, I think the angle helps when you have this on the kickstand and, you know, you put this guy into here. Okay, now first of all, it fits nice and snug. So it kind of angles away just slightly. It's not a big deal, but anyway, I think that's why they do it. So, yeah, these guys fit nice and snug like they should, right? Okay, then you have the tips. Very sharp tips. Okay, now this gray plastic is very hard, and this stuff is kind of soft textured. It's not soft, like I can squeeze my fingernail into it. It feels like I kind of can. Yeah, I can kind of scratch it. So the strain relief on these, you know, you got just your basic strain relief on both ends, right? So that's what they look like. And then these leads, the infamous, look at this, the infamous Fluke crappy, I think the TL75, man, look how stiff those things are. I mean, yeah, these are just terrible leads. Oh, I've lost the little caps. They have those little caps that just flip off. Oh, maybe I have them in my thing here. No, shoot. I think I must have lost the little caps. They come off so easy, they just pop off. But yeah, just your basic leads. They are also sharp, totally different kind of points on them. So a little bit different. But yeah, so they kind of have a softish kind of, you know, traction-y feel to them. So in that sense, they're similar to these. But yeah, anyway, you probably just have to, you know, basically just have to buy. I mean, you can see how these things just hold their bends, right? Look at these. Just since I've unraveled them, you don't see any sharp bends like that, right? See some, yeah, anyway. You can see how these guys just keep their shape. It's a kind of cheap PVC. But anyways, everybody knows about those leads. So, all right, so let's get to some testing. Oh, let me just push this in here, just show same kind of tension, you know, you can slide in and push on. So same kind of feel. These actually feel like they go in a little bit easier. Let's try, maybe it's the lead. Yeah, these kind of have a different feel to them. But anyway, okay, so let's get some measurements. Oh, and by the way, just real quick, I do have the Fluke 117 here. This meter's a bit more expensive. Add another $100 to it or something like that. This guy's like $234, I think it is, at Fluke. So you might buy, you know, probably find it a little cheaper than that. But yeah, so this one's even more expensive. This one's made in Malaysia. I've done a video on the Malaysia meter versus the Chinese Fluke. And so, yeah, I'll try to put the link down below for that. Now this one is third-party tested. Hey, you know what? An interesting thing. These Flukes, the 15B plus, 17B plus, and 18B plus, they're really never meant, from what I understand, to be sold in the United States. They're meant for the, you know, the Asian market, like be sold in China. And so that's interesting, right? The 18B plus, I think I had to go on eBay to buy this. The 17B plus, 15B plus, I see you can get them on Amazon now, but they weren't really meant for this market. And I think maybe that's why they only got the CE rating, not the third-party safety. Costs more money to do that. But I would think that these things should be a lot cheaper than they are, you know? So come on, Fluke. At this price, start making them in the US again. Another thing this has similar to this guy, both 1-year warranties, okay? Same warranty, made in the same country, have same safety rating. So far a lot of the sames, right? Except for the Ziboo has better specs, okay? I'm going to show you another very important spec. Well, I'll just tell you, this is 4,000 count, 6,000 count. We're going to show you what that means when we come over here and test, okay? Let's do it. Let's do some resistance measurements first, okay? Because partially, I want to show you these standard lead spacings. You know, when you have these kind of things, it's nice to have the standard lead space. Sometimes it comes in handy. When it does, it's just nice to know that they are standard. So standard lead space, okay, on both of them. Just want to show you that. Okay, let's leave it in there. So 9.9 ohms, 10 ohms. These things are supposed to be 0.05%, so okay. Make sure it's tight. Just leave it there for a moment. Okay. And put in this one. It's not really moving around. It's kind of locked in. So, you know, I think the method of measurement seems to be a little more solid with this one, right? Whether the accuracy is the same or not. I just like the way it dials in. Okay, let's do 100 ohm. See how fast it goes. Wow, that's kind of odd, right? Now, oh, you know what? So the one thing about these things, sometimes because they are rigid, sometimes it's the way they're tightened in there. So yeah, that it probably wasn't Whoops, I don't know what I did. Okay, so 100.6, we'll call it. $100.3. My guess, okay, 100.1. My guess is the 100.1, I think it's going to be close to 100 ohms. So 100.6, yeah, I think that's a little bit on the high side, but it's 0.5%, I think, in resistance. So that's about right, probably. Okay, pull over this real nice Hioki here. It says 600 mega ohms. It's over 100.02. See, I believe that. So that is the tiebreaker, I think. So it should be 100 ohms. Okay, let's do 10K. These guys should be pretty darn close to the 10.03. That's pretty fast, right? It's interesting how this reads resistance. Okay, 1001. It kind of settled into a good value. Let's just go back to the Hioki real quick. Look at that, 10K. So I believe that. And since we didn't do 10 ohm, let's do 10 ohm. Yeah, 10 ohms. That's funny. So 100K. All right, let's start off with the Hioki. 99.99. Oh, it just depends on how I've got this, you know, how well I've got this in there. $100.4. Trying to rock a little bit. It's pretty solid. Okay, that came right in at 100K. It's interesting. It takes a moment for it to kind of figure it out, but then it does. And this guy's just a little bit high on resistance, right? Now, again, that tolerance, it's within its tolerance, but it's on the high side. All right, so now I have this nice resistor. It's a Simpson. You guys know Simpson? The old, look at that. That is so cool. Made in USA. Okay, this is a 6 meg resistor. Let's get the leads here. Okay, 6 meg even. Let's get these leads. Six meg even. It just takes a moment longer with the Fluke, but it gets there. All right, let's do continuity since we're here. There's a little sound, ohms. Here, let's get this in the same mode. Sound, there's an auto turn off, ohms. It says manual. I don't think there is an auto range, so, okay. Because it's continuity, so yeah, of course it's going to be manual. There's no range. Can you hear it? 0.5 ohms. Pretty fast, right? Okay. Oh, we got a visual indicator as well. I think that's why it says LED here. Gives your ohms reading as well. Okay, so that's continuity. We could do diode, but let's wait for that one. Okay, let's go to volts. All right, so let's go to diode, okay? That's yellow. Okay, volts for diode. There's diode symbol. Volts, diode symbol. Okay, so here, let's do the Fluke first. This is a transistor, okay? I'm gonna go to base. and collector 0.473, and we'll go to emitter, just a touch bigger. And if I go, now one thing, listen, there's no beep, right? That's something on some of the older meters, they did it for some reason. They've gotten rid of that. And I think it's because if you're in a cube or on a bench testing next to someone else, maybe people didn't like to hear that beep, beep as you go test all your diodes. But it'd be nice to have the option, turn it on or off. Okay, open, open. Let's put the red one in the base. Okay, 0.5. That's really fast, right? 0.513, 0.496. That is super fast, isn't it? Boom. I don't notice the Fluke being that fast. It's pretty fast, but it does. Yeah, it's pretty fast too, right? You know, let's just go next door to the capacitance. Okay. It's kind of interesting. They're in the same spots. Okay, so nanofarads up here. We only have 3 digits here. We have a few more digits. You know, we have an extra digit here. Okay, this is a big old, what is that, 50 microfarad cap. Let's see. Okay, just took a couple seconds, no biggie, 51.7. Okay. Okay, I discharged it. Let's try again. Okay, that took a little bit longer, 51.24. But look, we get 4 digits, 51.24. Okay, back at the Fluke, 51.8. So we get, you know, takes just a little bit longer, but we get an extra digit. That's pretty nice. All right, this is a 470 microfarad, something I took off an amplifier. Get the black on black. Okay, there we go, 505. Okay, just took a little bit. I think it's going to take a little bit of time with the other meter. They have to charge up the capacitor and take readings while they're doing it. Kind of slipped on this one, but it took a little bit less time, probably 491.7. So I measured this on my matrix just to see what was closer, okay? And it came out 474. You can see it there, 473.9. All right, now we have a big old 10,000 microfarad. Let's try it out. This might take a minute. Well, it's actually going, might come up pretty fast. Wow, 8.91. Okay, that's impressive. That wasn't too long. This meter will go up to 60,000 microfarad. So that's pretty cool. It can do that. Now, I discharged it. So this meter isn't supposed to be able to read this high, so probably won't read it. We'll give it a try. It's only rated for 1,000 microfarads. Yeah, so it's just saying, it's not even trying. All right, guys, I've given this about 10 or 15 seconds, and it's not doing it. So I just kind of sped through so you don't have to watch. All right, guys, since I've got the leads in and everything, I just thought I'd show you something. So this has NCV, non-contact, but it also has live. I want to show you the difference. So NCV, so it says H. We get a visual indicator, red LED. That's pretty nice. Okay. The other thing you can do, which I like these live readings, is you can just come in here and touch it. Now I'm still on NCV, right? So technically, now is that okay? So neutral, there's hot. Okay, but if I go to live, okay, so I can go there and I can find my live wire. So that's pretty cool. I like the live and NCV both. All right, guys, so I have this red and black wire kind of just, you know, got the meters in parallel with that, okay? Then I put the meters from my power supply, the red one on this side, the blue one, or the, you know, return on this side, just so one would be on each meter, just to balance things out, make sure everything fair, all that kind of stuff. Turn on the backlights just to make you see it a little bit better. Okay, now what we're doing is I've got, you can see I got 1.79 volts coming out, right? My power supply says 1.799, 1.8, and pretty close to what we're getting out. Okay, I'm moving it up just small little fractions of a volt. Looks like my backlight timed out. So I just wanted to kind of show you, I'm going to bring up voltage a little bit faster, but I'm just going to show you what the display looks like when you're reading these voltages. So we're going to go to 3.3, common voltage. Okay. So my power supply says 3316, and that's what the Fluke says. The Ziboo's off just a touch. Well, actually my power supply is saying 3315 right now, so they're kind of in between. Okay, so let's bring it up a little bit higher. Okay, so I want to show you a 4,000 count meter. Once you get up to 4, you lose a digit. So we still have an extra digit over here that we can read. My power supply says 461413, so it's pretty much what the Ziboo's reading. Okay, you can see we get that extra digit, which is nice. Remember, the tolerance is like 0.5 plus 3 digits, so that's this last digit. So this last digit is kind of meaningless, so you only really got 2 digits. Over here, you just take that off, you still have 2 digits. So that's the advantage of a higher count meter. Okay, so now when I get up to 6, see how, so 6,000 count meter, now we're 6.1, so now we both, you know, we have the same number of digits again. Now, guess what's going to happen when we get to 40 volts? Okay, now we lost that digit, 46.1. We still have 2 digits over here. So remember, the accuracy is, you know, that 0.5 plus so many digits. So this could be 0.3 up or down, right? And so this one, you know, you still have a good digit after plus, you know, partially this one, like you have partially that one. But this one, in tenths, you know, this one's kind of an important digit, right? Now you notice also we got a flashing lightning bolt. We got a lightning bolt over here. So it's nice that you got this flashing thing up here. It's kind of warning you. You know, it's catches your eye a little bit more than just a solid one, right? Okay, so I just wanted to show you, you know, reading DC volts, what that extra digit of count does for you. You know, all the way up to 60 something, you know, volts, we have that extra digit. So that 6,000 count works at higher, you know, anytime you're looking at a display like this, whether it's millivolts or volts. Okay, let's go to millivolts since we're talking about millivolts. Okay, I'm going to bring my power supply up. I'm at 10 millivolts on my power supply. And see, once I went over 4 millivolts, I lost a digit. So I get an extra digit with the Ziboo. So my power supply right now is at 15 millivolts. So 15.1. Now my power supply dropped down to 14. It's going between 14 and 15. So see, we can see that activity right here because we get those 2 digits. This one rounds up, so we don't really get to see that the power supply is going up and down. It's moving around. Over here, we get to see it. Okay, so I set it for 19 millivolts. And let's see how rock solid it is. It's going between 19 and 18 on my power supply. And over here, you can kind of see it moving around. Over here, it rounds up, so you don't really know it's moving. So it continues, right? 25 millivolts on my power supply, but it's going between 24. It says 24 right now. 23. So it's kind of bouncing around still on my display. So we still have those extra 2 digits. Now, right there, it just dropped down. So now we're, got the same number of digits. Okay, now this one goes 300 millivolts. This guy goes, I think, 600 because it's a 6,000 count, so you can go up 600. This goes to 400, then we have to go to volts. So 460, we get 3 digits. We get 461 plus this extra digit. So that digit's not as meaningful, and this one might not be. But so you can see the value of a 4,000 count versus 6,000, I think, right? All right, guys, now I have this tied to my generator, and I've got 1 volt RMS coming out, okay? Now, if I go to frequency, it says frequency, hertz, and 500, which is what it is, okay? So, okay, 499.9, okay? And we have our little thing up here. I don't know. Maybe it's because we're on AC, it always puts that there, which is not really helpful because it's not really saying when I have a high voltage. It's just saying, oh, AC, scary, high voltage. It's not. So that's not helpful. But anyway, there's duty cycle. Okay. Now, I can come up here and do frequency and duty cycle. Okay. And the duty cycle should be like 50%, so it's, both of them they're within tolerance. You're just off just slightly, but they're within tolerance. Okay, let's go back to AC. So it says AC auto volts. We have the wiggly sign. And this guy here, we have AC volts and no wiggly sign, but, that's fine. Okay, now we're going to go from 500 to 6 to 7, 8, 9. Most meters are good up to 1 kilohertz, okay? Most lower cost meters. So we're still good, okay? Now let's go 2K. And yep, we're starting to roll off a little bit on both. 3K. Yep, we're rolling off really fast here. Not so much here. Yeah, if I go up to 4 or 5 kilohertz, so we're just continuing rolling off here. This is rolling off slower. Okay, now here, let's go back up to, 500 hertz. Okay, so there's 500 hertz. Okay, now we have a square wave. Okay, so we're still 1 volt RMS, so everything's good. Okay, now let's go up in frequency and see how that works. All right, there's 1 kilohertz. Let's go to 2K. Okay, and they roll off kind of the same way they did before. So square or sine, same thing. So that's a true RMS meter. That's a good sign, because whether it's square or sine, it should calculate true RMS. So it says true RMS, so that's good. And by the way, if you don't want the thing to automatic time out, you can hold the mode switch down, turn it on, it beeps at you, and you don't get the timer anymore. So now it's turned off. See that? All right, and then in frequency mode, if I'm at this position, it gets, you know, I'm limited, okay? But if I go up in the hertz here and compare it to the hertz here, 106K, this guy is spec'd at 100K. So if I go 116, he does it. And then 130K, he can't do it anymore. So this guy's still in it. So let's go up a little faster. 236. 1 meg. Wow, look at that, 10 meg. Okay, this guy's spec for 20 meg, and it's gone. So it can't quite get the 20 meg. All right, so 17 meg it's good for. Yeah, so about, yeah, almost 18 meg, okay? So it's doing pretty good, right? All right, guys, so now my generator is going into the current here, the microamp input on the Fluke. It's coming out of the common, going into the microamp of the Ziboo, and coming out of the common back to the generator, okay? So right now, I have 5 millivolts RMS coming out of the generator, and we're getting 19.8 microamps, okay? And they're both green. So let's go back down to 1 millivolt. Okay, let's go a little bit smaller, see what we, maybe that's as small as I can go on my generator, 1 millivolt. So, okay, now we're going to crank it up. Okay, there's 10 millivolts. And we're getting, you know, I'm sure it's within the tolerance, because, let's see, AC, I think is 1% on this and 0.8% on this guy. So let's keep going up. I just want to go up and get another digit. Okay, on my generator, it's 50 millivolts. Okay, interesting. Now, it's going to be, so AC millivolts on this guy is 3% accuracy with 3 digits. That's what it is, okay? AC millivolts on this guy is 0.8 with 3 digits. So this guy should be a little more trustworthy, right? Should we check out and verify? 276.5. Yeah, pretty darn close. So I think that tolerance looks pretty good for this guy, right? So this one's off a little bit more, 276 if we believe the heel key, which I do. So yeah, there we go. That's microamps, AC. So you can see how the display differs a little bit. AC microamps, microamps AC down here. Auto, this guy gets a little wiggly. Okay, let's go up a little bit higher. Now 4,000 count, we're going to probably lose a digit there, right? Yep, we do. So now we don't have any decimal point. So that's what a 4,000 count. 6,000 count, we can go up a little higher until we get there. Okay, 437, I guess I got to go to millivolts now. Or milliamps, I mean. AC. Okay, 723. Okay, so I'm getting a decimal point in 3 places. We're getting the same reading. Okay, let's go to milliamps. All right, we'll keep on going up. Again, when we get to 4, we know it's going to happen, right? So we lose that decimal point again. And here we'll keep it until we get up to 6. So if you're looking at 5 volts kind of stuff, you're going to have same kind of thing. You're going to have an extra digit where you'll lose a digit on this one. All right, guys. So I just want to show you a few things. Like the case on this one, very similar. It just has kind of a ridge where this thing sits on, so it kind of pulls out easily. And on this one, I'll pull it out. There's a little seam in here that this guy tucks into. So when you take it apart, you got to spend a little bit more time to get it all tucked in. But once it's all tucked in, it's nice and tight. So now the kickstands, pretty similar. Okay, hard plastic. Now this has the little thumb screw thing here for the battery. Can't quite get it all up, maybe. Okay, and then you get it just right, and then it pops off, and you got your batteries in there. Okay, so, all right, got to be careful with these copper tops, right? But anyway, has a little piece of foam in here, has little ridges in here, has the other, parts of the connections there. So it looks like the connections in series, and so it only needs these connections just to complete the series path. Okay, so tuck that up in there. I'm gonna have Phillips take that guy out. All right, the other thing I want to point out is this has a hard plastic thing where you put the little hanger in here, where this it's built into the case. It's just the rubbery thing here. So they both have these grippers. These are probably a little softer than these. These are a little more rigid. They both have little protective things down here at the bottom. This one is designed with the angle, so when it sits up, and yeah, anyway, pretty similar. Okay, the screws retained in the plastic, and we have the ridges here too. And this one's taken 3 batteries. Okay, and there's our fuses, so we have access to the fuses right here without having to take it all apart. So that's pretty nice. So yeah, pretty cool. Now, this one also comes with the red. If you don't like the yellow, you can replace it with red. I did want to show you that's a metal retainer in there, a little pin for that screw. And then here's another screw. The compartment, in case of leak, looks like it's pretty sealed up. That's pretty nice. All right. I knew you'd want to see the inside, so I've loosened all the screws, I hope. Maybe there's another screw in the battery compartment. Yeah, maybe. All right, so I had to loosen those 2 screws too. And look at this, calibration seal. I think that's kind of a joke. I'll show you why. And it's just you seal the compartment and then you put a little teeny sticker on like that. That's kind of a joke. And so, people make a big deal of the ridges, like how secure the thing is, but you can see how they go in. All these companies have been doing this for a long time. So anyway, here's the 2 contacts, okay? There's where they touch on the board. There's the 2 screws, and that little plastic seal is covering this. So those are little measurement points where you can take measurements. There's no calibration pots. Hopefully there's not. That's old, antiquated stuff. That's gone a long time ago. But you can see the fuse here, okay? And then the other one here for the milliamps. You can see the bridge rectifier for the protection. And you can see probably a resistor down here. And these guys are MOVs, these blue things. Okay, and this green one's a PTC, so it's kind of like a fuse, right, with the big resistor here. So, nice safety stuff. Here's your little current shunt. Another big 3-ohm resistor for safety, and then here's a little guy for shielding. There's a capacitor right here. It looks like a poly cap, and then it looks like some things to keep voltage separation. There's a little slot right here and another little barrier right here for the PTC. So that's kind of your protection scheme. And you got your chip, you know, this, you know, a glob on a chip or whatever. Here's your little buzzer, crystal. This looks like an inductor maybe for the power supply right here. So that's your board. Okay. Let's open up this guy. Okay, now this one had the 4 screws and 1 screw in the battery compartment. Okay, I'm going to dump those screws out here. Okay. So again, the big ridges that go down inside these, you know, for the channel. There's our glob on a chip. So, okay, and you can see this barrier I built around the fuses for the isolation. Okay, so same kind of thing on here. There's these fuses, one's kept inside here and one's kept down in here. So everything's, you know, isolated. Okay. Now we see our shunt right down here, right next to the pad where it comes from. And we see our 2 PTCs, and wow, look at this, 5 MOVs. We're over here, we had 3. So, and we have 2 PTCs. So, man, talk about protection, right? Now, where this one had the bridge rectifier right here by my thumb, this one has 4 individual diodes, okay? And then we see some transistors here too. And we see a string of resistors here to make up a high voltage resistor, probably to make up that resistor, okay? And then another string of them. So, yeah, so that one, a little bit bigger resistor that one's mapped for. But yeah, you can see construction difference. Our buzzer, our crystal, a bunch of transistors. And we do have 1 aluminum electrolytic. So that's not as good as having like a tantalum or some other type of capacitor. Like we're here, we have these 3 yellow tantalums, and then there's more yellow tantalums up here. This guy looks like he's probably mostly ceramic capacitor, except for this one aluminum. So if it's worth $100 to get rid of that, you could probably just unsolder that, put a tantalum on there. Now the other thing, the terminals themselves, you know, they're almost identical. The method they're done, right? So yeah, not tons of differences between these. Oh, you may have noticed these had the 2 smaller fuses. And for a Cat 3, I think that's probably just fine. They do have the UL marking, they're Rio Max fuses. So 1000 volt rated, 600 milliamp and 10 amp. So that's the 600 milliamp up here, the 10 amps down here. The other thing I want to point out is that is the non-contact voltage antenna, that little strip of copper right there. You see the little line come down here, comes... Geez, I don't know where it all goes. But anyway, that's what that is. Oh, and then just point out the battery terminals. They're opposite sides here. So, you know, one thing I do want to point out, these MOVs and the PTCs, if you notice, the PTCs are similar in size, right? But the MOVs, if you notice, like how much thicker and bigger in diameter, like see the diameter of this one compared to the diameter of these? You can tell, put them close together. You can tell the diameter difference, right? The diameter and the thickness determines how much energy, how much material there is for protection. So these guys are some beefy, you got 5 beefy MOVs versus the 3 on this side. So that is interesting, right? Oh, and the other thing I just want to point out is these bridge rectifiers are 4 diodes. If you notice there's a 5th diode, these are to steer the spike and then that guy is to kill it. Okay, so you see how there's 4 and then there's 1 down here? That's what that's the idea. Okay, just want to point that out. One more thing, just for fun. Oh, the battery still works. Awesome. So this is a meter I bought many years ago, and it was the beginning of these lower cost small meters. I think this one's actually kind of cool. Like if you're putting on a belt or something or hanging it for electricians where the leads come out where they're not in your way. Now this guy is actually made in the USA. So pretty cool. Bring them back, guys. Bring Fluke's meters back to USA. All right, guys. So what do you think? Is it worth buying the Fluke for $100 more? $149-ish versus $40, $39.99? Or you can spend an extra $10 and get a temperature sensing, which I don't know if it's worth it. I think $40 is a pretty sweet deal. But if you need the temperature, yeah, there you go. You can buy both of those and still have, you know, $50 saved versus buying one of these. Now the 17B Plus has more of the features, has max min, relative. This one does not have the relative, but it has max min, which I didn't show you that. But it does have the max min, and the 17B Plus also has that relative, where the Ziboo has the VFD, the variable frequency drive. So it's supposed to, you know, cut out that, you know, filter that high frequency stuff. So what else? Yeah, you know, the tolerances and that, the Ziboo looks like it's doing better, right? So, all right, guys, let me know what you think. I want to give, here, hold on a sec. I want to give 2 big thumbs up to Ziboo for sending this meter out for me to review, to show you guys another alternative. I love to see Fluke, especially at these prices, bring them back to the US. I mean, I think there's some people that would pay the extra money just to get a USA made meter. So yeah, bring them back, Fluke. If you don't, drop the price. I mean, that $140, $150 seems crazy high, especially when it doesn't even have third-party safety certification. So yeah, $40 for the Ziboo all day long. If you don't like the yellow, you get the red case on there. So have something different. Anyway, there you go, guys. Let me know what you think. 2 big thumbs up to my patrons and my YouTube members, especially Danny for being a team member. You become a member of either the Patreon or the YouTube thing for like as little as $1 a month. But you can just subscribe. I really like that. Subscribe, like the video if you liked it. I like to grow the channel to 40,000 by the end of the year if I can. We just started August. We're just getting in August. Can we do it? You know, there's about 75% of the people that watch that are not subscribed. So just get a few more of those guys. We can make it. All right, guys. Thanks for watching. Oh, you know what? The Ziboo also has like a current clamp that came with it. I didn't show you that because I didn't have one for the Fluke, but yeah, it has a current clamp thing, and I gotta look at the price on that. But yeah, that way, if you want to just clamp onto something, you know, like if I'm taking the AC power measurements and that. Now, I think the clamp on they have does AC and DC, but yeah, if I'm reading current, it's way safer to use a clamp than to run it through your meter, right? Even with those nice fuses. But yeah, I like clamp on meters for measuring current. Yeah, at the bench, different. But I'm talking about when I'm outside of a category 1 or 2 environment. If I'm in category 3 or 4, I'm definitely using a clamp on. So, all right, guys, thanks for watching. We'll see you next time.